Welcome back to mathsolver 1117. If you are the kind of a person who loves brain twisting puzzles and solving the hardest math problems in the world, then you are in the right place. Today we are tackling an actual IMO 2024 question, a problem so hard it left thousands of students scratching their heads. So don't worry, I will guide you step by step, and by the end of this video you will understand it better than most. So we will solve this problem. Problem is, let q be the set of rational numbers. A function fq goes to q is called if the following property holds for every xy belongs to q such that f into x plus f of y is equal to f of x plus y, or f into f of x plus y is equal to x plus f of y. Show that there exists c belongs to set of integers such that f there exists at most c different in the form of f of r plus f of minus r for some rational number r. Find the smallest possible value of c. We solve this question in a very easy and simple way. So first of all, we will consider the two equations such that f of x plus f of y is equal to the f of x plus y, and name this equation as equation 1. Then the other equation, f of x plus y is equal to the x plus f of y. Name this equation as the equation 2. After that, suppose if f of y is equal to 0 and condition is that y belongs to rational number q, then equation 1 will become f of x is equal to the f of x plus y. This implies that y is equal to 0. So we get that f of y is equal to 0, which both ways implies y is equal to 0. So now we will get from equation 1, substitute x is equal to 0. This implies that f into f of y is equal to the f of 0, put x is equal to 0 plus y, and from equation 2 we put y is equal to 0, which implies that f into f of x is equal to the x plus f of 0. So this implies that f of 0 plus y is equal to the y plus f of 0. So which is consistent. Now we suppose that Let's suppose f of 0 is equal to the k. Then f of y will be equal to the k plus y. So now we apply f on both sides. Apply f on both sides. Both sides will give you the f into f of y is equal to the f into k plus y. So this implies that f into f of y is equal to the f of k is k plus f of y. So we get that f of k plus y is equal to the k plus f of y. This means f is linear with slope and satisfied by the k. Now we will solve another case. Now we have case 1, that is, let's suppose f of x is equal to the x plus k. We supposed it. Substitute this in the equation 1 will give you f of x is equal to x plus k. Then you get that f into x plus f of y plus k is equal to the x plus k plus y. And solve this further will give you f of x will be the x plus y plus k plus k and plus k. Then this is equal to the x plus k plus y. This implies that x plus y plus 2k is equal to the x plus y plus k. So these are cancel out and you have 2k minus k is equal to 0, which implies that the value of k is 0. So the equation 1 holds such that f of x is equal to the x because value of k is 0. If f of x is equal to the x, then f of r plus f of minus r is equal to the r minus r. And this is equal to 0. This is the solution for case 1. Now we will solve for case 2. Now for case 2, you will just change the value of f of x, that is equal to minus x plus k. So substitute this value in the equation 1 will give you that x plus f of y plus k and use the is equal to the x plus k plus y. So this implies that x plus minus y plus k is equal to the x plus y plus k. So we get x minus y plus k is equal to the, and also plus k is used in place of this, is equal to the x plus y plus k. So x and x are cancelled out from the both sides, and you get 2k minus k is equal to y plus y, which implies that 2k, k is equal to the 2y. Now this must hold for all y, and which is impossible unless k is not a constant. So this is the contradiction to our assumption. So we will say that this is not possible. K is equal to constant. That k should be equal to some constant. So we will say that solution does not hold for this equation. So you will say that f is equal to minus x plus k is not solution. Now we will consider the other equation. Now consider the second equation, that is f into f of x plus y, that is equal to x plus f of y. We will solve this if we see that f of x is equal to the x plus k, then this equation will become as, by applying the f on both sides, x plus k plus y plus k, and right hand side is equal to the x plus y plus k. So we will get x plus y plus 2k is equal to the x plus y plus k, which implies that k is equal to 0. So when k is equal to 0, it's mean that equation 2, that is f of x is equal to x, holds. Now consider this, if f of x is equal to x, then f of r plus f of minus r is equal to the r plus minus r, which is equal to additive identity. Now we will consider the other case, that f of x is equal to the minus x. Substitute this value in the second equation, you will get that minus into x plus minus y, and this is equal to the minus x plus y. Then this equation will become minus x plus y is equal to the minus x plus y. So this holds. This value we get from equation 1. Now we will apply this value in the equation 2, then it will become minus into minus x plus y, that is equal to x plus minus y. So this also implies that x minus y is equal to x minus y hold. This is for equation 2. Now we see that f of x is equal to the minus x is satisfied. Then if this is equal to minus x, then we can say that f of r plus f of minus r will be equal to the minus r, then plus into minus r. So minus r and plus r is equal to 0. So this is also whole. Now we will consider another case. Consider the another case that f into f of y is equal to the k plus y. Then the function will become as, if we consider that f into x is equal to the a of x plus b, by applying this you will get a into a of x plus b is equal to the k plus x. So it's mean a square x plus ab plus b is equal to k plus x. This implies that a square is equal to 1 and a square is equal to 1. So a is equal to 1 or a is equal to minus 1, we will get two values. So if we say that a is equal to 1, then 1 plus b will give you b plus b is equal to the k, which implies 2b is equal to k. So f of x will be equal to the, in this case f of x will be equal to the x plus b, because the value of a is 1. So we found b is equal to 0. So f of x is equal to the x. Now if a is equal to minus 1, this implies that minus b plus b is equal to the k, which implies that k is equal to 0. So we have f of x is equal to the minus x. We found this works. So we say that the values of f of r plus f of minus r is equal to the always 0. So this always work. So this is the complete solution of this question. If you found this video helpful, subscribe Math Solver 1117 and also hit the bell icon to get notification for more upcoming videos. In the next video, we will solve more interesting IMO questions from the past paper. Stay tuned. Best of luck for your IMO exams.